Hello and welcome to another Solana tutorial. Today we're going to talk about the Solana keychain, which is basically a framework to help you sign with different signers. So basically it contains the individual implementations of different SDKs with this one interface. And so we then just plug in this one Solana keychain interface into our application, whether that's in Rust or at the kit, and it just makes it much easier for us devs. And Jonas made a nice little video about that, and I like Jonas's videos. They're nice and sweet and short, but they often leave me with more questions than answers, because he's talking about so many different signing possibilities that I haven't even heard of. So today, I want to have a look at that and have a closer look at the Solana keychain myself, also implementing that with a kit and then plugging in at least 3 different signers, namely a local Keypair, which is what I'm used to, Turnkey, and Privy. And those 2 I haven't used before. So we will have a look at that. Let's get started. Let's get a local Keypair, lock PV. I transfer 0.1 sol there. Okay, and as for instructions, we can get a transfer sol instruction that will send from my payer to the receiver amount 0.001 sol. How about this? So nothing special here. This is a transaction sending script as we're used to it from the kit. This is how I always do it. I create myself a Keypair signer from this local Keypair file. Then I connect to DevNet, get a block hash, create this instruction, create a transaction message, sign it, and then send and confirm this transaction. We're not using the Solana keychain yet. I just want to see if that works. But also let's get a memo. From memo, we get an add memo instruction. Memo is using local Keypair. Good. Can we send that? Let's see. Yep, there we go. We sent the transaction with our local Keypair, and Andy got his 0.001 sol back. There we go. Using a local Keypair. Amazing. So that works. Nothing unexpected here. Let's try and do the same thing with the Solana keychain. And like this, I'm importing everything. Let's look here. It's a project of Solana Foundation, so that's one reason to trust it. Another reason to trust it, it has been audited. Here's an audit report. And we see it's a flexible framework agnostic Solana transaction signing thing. Or the Solana keychain supports flexible framework agnostic Solana transaction signing. That's how you should probably read this. It provides a unified interface for signing Solana transactions. That's what I said. Interface. It's an interface with multiple backend implementations. Whether you need local Keypairs, an enterprise vault, or managed wallet services, this library offers a consistent API across all signing methods. Great! And those are the signing methods that it supports. It supports them both in Rust and in TypeScript. And TypeScript, that's what we're using, the Solana kit. Let's see docs. It's compatible with Solana kit and Solana signers. Nice. And those are the individual packages. And here, that's what I meant. If I add Solana keychain, then it adds all of them. If I just want to add a specific one, then I could do that with the individual packages. However, it's tree shakeable anyway, so it will only use the ones that I'm actually using. I don't mind if I have downloaded the packages for nothing, whatever. And the first one I want to look at is this one, the memory keychain, which is for in-memory Keypair signing. So a local Keypair. Essentially, it should be the same thing as I'm doing here, just that we're using the interface from the Solana keychain. So how is that done again? Create keychain signer. So there are the individual ones, and I guess keychain signer dispatches to the correct create signer based on the backend. So that's fun. I can say signer is create keychain signer, and then based on what I put as backend, it will use the correct one. So for instance, if my backend is memory, then this will do the same thing as if I say create memory signer. The advantage of using it like this is that this one will directly tell me what I need exactly. Is that also smart? Oh, that is also smart enough. As soon as I have the backend correct, it will also tell me those are the things I need for the memory signer. That's fun. That's to say that this is the exact same as this, and I just need to put in the correct things here. And it looks like all 4 of those are optional, meaning I guess I just need to provide one of them, right? Because if you have the key pair, that should be sufficient. If the private key, that should be sufficient. If you have a private key path, that should be sufficient. If you have private key string, that should also be sufficient. So depending on which format you want to put in your key, either as a JSON file or as the base64 encoded string or whatever. Let's see, what does it take? A base58 encoded private key or a U8 string. That's fun. It takes both. Nice. Wonderful. But what we have is a local file. What would Keypair take? That's a pre-built crypto Keypair. Okay, so that's if you're using the crypto library directly. Private key is the raw bytes as a U8 array. And it either takes 64 bytes as the seed and pub key or just the 32 bytes as the seed. So the private key. Nice. So they don't call that private key. They call this the raw seed, and then the entire thing the private key bytes. But in a way, the private key is the seed for this, right? Or is there still a difference? Terminology is still a bit confusing, because would you call the entire 64 bytes private key? Kinda, but it's like seed and public key. I really like to just think of the seed as the private key, because the other thing is a public key. And if you just provide 32 bytes, then the public key is derived. Anyway, so I could just provide the bytes, or I could provide the path to the bytes, so to a JSON file. And this is for Node only, but we are in Node, we have the FS. So I guess I can just provide this and that should be fine. Let's go. And then I'm gonna rename this to signer and remove this. Okay, what is this signer though? Oh, that's a promise. So first of all, I need to await this. And then we get a Solana signer. I don't know if that's a transaction sending signer or if that's a partial signer. What type is this? When we talked about signers with a kit, we made those distinctions. And I guess it depends on the backend. Okay, so we're now using a memory signer. Let's see if that also just works out of the box. Memory signing. Nope, does not. No exports. How do you use this? Add type module to your package JSON. Okay, Claude, if you say so. Try again. There we go. Look, now it works. I can just use this keychain signer with a memory backend to send pretty much the same transaction as before. It's even using the same key. And I'm again paying Andy back and sending a memo. We're using the memory signer. Perfect. So this stuff also works. Nothing unexpected here. We basically just changed one line and now we don't need to weirdly import our JSON file anymore and make it a U8 array and then convert that from binary. That's all hidden in here now. So for that reason alone, it's convenient to change to this keychain memory signer. But the real advantage from the Solana keychain comes from now being able to easily change the underlying key. So not just signing with a local Keypair as I'm used to, but for instance, using a service like Turnkey or Privy. So let's do that. Let's start with Turnkey, because why not? As I said, I never used this before, it can't be so hard. Okay, so I could use a security key or I could use device biometrics as an authenticator. I think I'm gonna use device biometrics, because why not? I would also have a security key here, but I think this is easier. So I just looked into my camera and then it says, hey, that's great. A label for this authenticator, solandy authentication. My organization, Solandy. Let's go. Get started. Cool. That's what that looks like. I'm the root user. Sign your first transaction. Navigate to the dashboard, create an account, set up your organization. We just did that. Get an organization ID. Yeah, that's my organization ID. I have that. Copy it and use it in your code. And see, this is what we will need to put in here now if we use Turnkey as our backend. And Turnkey will require all of those things. That's a lot. But the organization ID, I already have that. And you should probably not show this to everyone. But this is just an example. I'm not actually gonna do anything with that account on Turnkey productively. So I feel okay showing this to you. But usually those things should all be in environment variables and be hidden from the actual production environment. So don't commit them in your source and don't hard code them, just the usual. But for local testing, you could do it like that. And me, I'll do it like that, such that you see what I'm doing. Because this is a tutorial, yo. Good, we got that. Create an API key. User page, create API key. User page, create API key. via the web app or CLI and provide the public keys. Okay, I think I'll use CLI and enter the public key. What? The Turnkey CLI generates an API key pair and stores the API private key locally. Oh, that means I have it locally. I see. Yeah, maybe that's not what I need. Maybe I want the other thing. Maybe I want it in the browser. Let's see what that does. I'll just give it a name. Okay, my first turnkey. Save your API private key now. Copy the API keys below and save it somewhere safe. They cannot be recovered. So basically, this guy is just creating a key now, and I should not show you this unless I want you to be able to use that same key, which I'm okay with. I could download this or just copy this. So the private key, that's the important part. The API private key and the public key. There we go. And then what else you need? The private key ID and the public key. Okay, note, you will be asked to authenticate. Approve. Okay, so if I do this now, then it will actually create that key or something. Okay, I signed up with my thing. We created an API key. Great. Back to activities. You ready to start developing? Okay. So this, the Turnkey API private key for this authentication, the public key for this authentication. And then those things, what do I still need here? Private key and public key. This is the Turnkey private key ID used for signing Solana transactions, and public key is the base 58 corresponding to the private key ID. Okay, so how do I find out what those are? Let's see, wallets. Maybe I need to create a wallet. I have a user, I have created an API, and then wallets are a collection of crypto accounts derived from the same seed, or private keys are key pairs that can be used to sign and verify messages. I think I'll just create a private key, my first turnkey key, and I will use the ED25519 curve because that's what Solana uses. I will select Solana as an asset, why not? And private key tags, I don't need that. Approve. And then it will again ask me for my biometrics, so I gotta authorize this. Here you go, completed. So now I should have a private key, my first turnkey key. And the private key ID, is this what you're asking? Yeah, the private key ID, cool, I found it. And the public key, so how do I know? Yeah, the address, the Solana address. Yes, that's what I need. Look, that's the missing piece. So that will be my address. So now I know that that's my address, so I can fund that and be like Solana transfer 0.01 sol to this address and allow unfunded recipient. I keep doing this wrong. It's first the address, then the amount. There we go. And then let's see if we can just use Turnkey for signing. I imagine there must be another authentication step, but maybe there's not. Maybe if I just provide this, then it will just handle all of it with Turnkey. We'll see. Yes, it does. Fun. So now that I created this, and that's the reason why you should not share your private key IDs and the API keys and stuff, because if somebody has all of that, they can sign for this address using Turnkey. And I don't even know how it's done. I don't even know how Turnkey works, right? I don't even know what sent where. I have no idea about their SDK or their API. This is all hidden behind this keychain signer. So as a Solana dev, I don't need to worry about it at all. I can just put all my secrets here and that will just work using Turnkey signer. Yeah, worked again. And we see also here we can send Sol from this address, and we did use a Turnkey signer. Amazing. So this transaction looks like any other transaction. From this we can't say that this was a Turnkey signed transaction, but it was. Freaking easy as that. And the cool thing here is I could add policies or analytics. Look, I signed 2 transactions today. It's pretty fun. Yeah, nice. So yeah, the solana-keychain provides this nice interface that I can just put in the Turnkey specific things and it will handle the rest for me. And it will also do that for a bunch of other SDKs like AWS or GCP or Privy, which sounds nice, but I've also never used that. So let's see what that is. Wallet infrastructure. Get started. Success. Welcome to your dashboard. Project or company name. I don't have a website. Just me. Let's go. App name. Solandy's Privy app. Cool. So we have an application where again we will get API keys. Nice. So let's already look here. Privy. If I were to use Privy, what would you need? The app ID, the app secret, and the wallet ID. And then I already renamed this to Privy. Okay, app ID, I can copy that from here. Here you go. The app secret, I can not directly copy, but how do I get there? Privy doesn't store your app secret. Please be sure to store it somewhere safe. Well, I gotta create a new one, I guess. What? I create a new one, which I can copy. Interesting. Yeah, I'm just gonna copy that. Privy app secret. Again, don't show this, because it's a secret, damn it. But again, it's just I'm not gonna use this, that's why I can. Because I'm just too lazy to blur this stuff out. Besides, then you don't know what I'm actually doing. So yeah, we're gonna leave it. And yeah, what else did you need? A wallet ID. Okay, so that's for the app, and then somehow we again need to work with wallets. So let's see, wallet infrastructure, wallets. I have no wallets yet, so let's create one. My first Privy wallet. I want it for SVM, Solana. Servus. This is an inside joke you will not get because it's from a German film. Anyway, policy. Oh, I can do policies here. None. Yeah, I take that. Owner, optional. If set, all updates must be signed with the owner. Yeah, whatever. Additional signers. These signers can sign for this wallet. Okay, whatever. I'll just create this one. Wallet. Okay. Oh, okay. So in this wallet, I do have a public key already now. And you want the wallet ID, which is the Privy wallet ID. Well, but what's the wallet ID? Is that, what's the ID of this? The wallet ID. Ah, okay. So here it's just a random hashy kind of a string here. That's the wallet ID that will correspond to this public key. So it's not interested in the public key, but in this wallet ID. Wow. Good. Then same thing as before, we Solana transfer to this address 0.01 sol and allow unfunded recipient. That's what I said, right? And then we see if we can use this Privy signer. And yeah, out of the box, let's go. Again, the transaction will look pretty much the same. We're just using with this different wallet now. That is our wallet here in Privy, and we're paying Andy back, and we're using a Privy signer. Pretty sweet, eh? Yeah, I would say so. Pretty sweet. So yeah, this is pretty cool, the Solana keychain. Literally, you gotta just put in the right app IDs and wallet IDs and whatever, and all the rest is handled by the Solana keychain. Me as a dev, I don't need to write different code for different SDKs. I don't even need to understand how they work, because somebody understood it who developed this, and now I don't have to. So that's convenient. And we saw 3 different technologies, and to us basically the exact same code. We don't need to change anything in our transaction signing. That's all handled still by the same functions of the kit. We don't need to worry where that signer comes from. We don't need to worry where the private key is stored. It's all abstracted away, and we just have this interface of this Solana signer here. That's pretty cool. And I could keep going through more. I could use AWS, I could use GCP, Fireblocks, the Vault, whatever that is, Crossmint, CDP, OpenFort, Coinbase, HashiCorp. What's that? HashiCorp Vault instance with transit engine enabled. HashiCorp. Sign up for free. Oh, this is the first one asking me for a password. The others are like, we don't care about passwords. We know that that's not safe. There we go. So, personal. Yeah, whatever. I take that as an org name. Okay. And what do I do here now? I have no resources. Why did I sign up here actually? Do I even need this? Wow, I have credits. Vault dedicated. Get started with Vault dedicated. Quickly deploy a Vault cluster using pre-configured template. Create a cluster. It's using AWS. Vault tier development. Extra small for $1 an hour. Same price on Azure and whatever. Let's go to Frankfurt because that's closer to me. Vault cluster. Estimated to cost me $444 a month. Whatever. I can afford that, lol. I'm still not sure if that's actually what I need. I'm just playing around. App integration. So that's how it all works. But again, I don't need to understand this. I'll just set it up and use it. Fully managed implementation of Vault Enterprise. Do I actually need this? I think I would also be fine with a not enterprise version. There, Vault. Oh, I could just install it. Yeah, I could just install it locally. I don't need to run it on AWS. That is probably the smarter way to go about this, actually. Again, this would be the enterprise version. This would be the I just do it at home locally. Let's do that instead. Let's update. and install the vault, hashicorp.com. The vault. What's that? Cool. Vault TLS key and certificate has been generated. Cool. Let's do vault signing and use the vault backend. And then I should have vault here. Yeah, look. But I don't know how to work with this. But there's a prerequisite thingy here. I'll just do those things. I'm gonna enable my secrets to transit, address unset. Okay, so how do I set up this thing? Status, server, start a vault server. Server, damn it, at least one config path. -def. There we go. Okay, what does that do? Have a server running now. Dev mode is enabled. Vault runs entirely in memory and uses a single unsealed key. That's fine. That's just for testing purposes anyway. User key root token. This is not for production installments. Okay, cool. We have a server running and this is my root token. Root token. I gotta get that here. And then, there we go. That's better. Cool. Got that thing running. Then let's try those things. Success. Enable transit secrets at transit. Then I write into transit Keypair, my Solana key with the ED25519 type. Let's do that. So we're basically creating a new key. Okay. Keys. Public key. Look. Here we're seeing a public key. But that's base 64 or something like that. That's not the format I like, but doesn't matter, whatever. Export public key to get your Solana address. Let's see. Error making API request. Private key material is not exportable. Didn't we allow that? Exportable is false. I mean, I guess that's safe or whatever. Okay, what would my vault signer need now? The key name, the public key, the vault address, the vault token. The vault token seems to be the root token. Okay, so that is what we got when we started the server. I don't know what it is, what we started, the vault thingy. The vault address, that's what we set here as well. Actually, what happens if I call this? Oh, look. Sign into vault. But how do I get a token? Guess I would need to create a user or whatever. I don't know how this thing works, nor do I want to find out. I just want to be able to sign with this key now. Or maybe, hold on. Can I have exportable just for demo purposes? Quick fix by Claude. Okay, I guess I gotta delete it and then rewrite it with exportable true. Okay, delete it. Success. Data deleted. Write it, and now we have exportable true. Cool. So this is my different pub key now, my Solana key again, and then now we should be able to read this. Yeah, look. But this still doesn't look like a base 58 encoded key at all. Public key, my Solana key. I could have just read that. Wait, I just needed the public key anyway. I don't need to export my key. This would read the private key and the public key. I wouldn't have even needed that. So I could have just read the public key of my Solana key, then I wouldn't need the entire signing key. Okay, anyhow, now I get this, but this is still base 64, so I will get base 64 codec and decode this, encode this, and then I get a base 58 codec and decode this, and then hopefully, wait, let's do that outside so I can print it. And we see, okay, we do get something that looks like a Solana public key. Vault address must be HTTPS. You know what? Screw you. HTTPS. Does that help? Network request failed. Now that I have this running though, so this is the same thing except now I don't have this running locally but in an AWS instance. So I could export this. Look, let's see this. So if I did this, and then we need to authenticate with the vault token. But what's my vault token? Generate an admin token. Copy it. Put this here. So I'll also already replace this. And this vault status, look, this is running now. This is on AWS. Nice. Let's see what I can do here. Can I allow this? Enable to transmit secrets. Then we write a key. Let's go. Okay, it's again not exportable. Okay, and that's the name of it. And so if we try to read, this won't work because it's not exportable, but I just want the public key anyway. And this is here, look. This is that public key. And if I put that public key here, and then I also change that address, what will happen? Let's see what happens. We'll see. I'm pretty sure I'll get a timeout. Okay, so we can't connect to this, so the network request failed. Shit, so the public, maybe I gotta use the public one. Yeah, look, this looks better. What if I use the public one? Try this. Then sign a remote API error. Permission denied. But it is trying to use that. Permission denied. Yeah, I don't know. Transit my Solana key, so I see it. I can sign. This can't be so hard. I am gonna vibe code my way out of this. Check the signer for a vault namespace parameter. I don't think it has that. Do you have a vault namespace? No, you don't. Need to authenticate a vault in order to create secrets. Oh, so that's the command and that's just setting the variable. Okay, let's do that. Let's see if I can do a scoped login. Token will be hidden. So here I put my admin token. There we go. And then I get a token that is this now. So that's admin. And this is the fully scoped token for admin, and maybe that way I can use it. Nope, still permission denied. Okay, let's confirm this quickly. Yeah, you are correct. The proxy is the only way to go. So it seems like they're not sending the namespace correctly, and then that doesn't work. So I would need an agent to handle that shit. Oh man. Okay. And I'm gonna do this proxy, and then I'm gonna run this agent from this vault agent HCL. Look, I have an agent running now. So this is basically translating my localhost onto this with namespace admin. That's all that does. And then I'm gonna put my vault address to this instead of that, such that this uses the proxy, and then we try this again with the vault signing. Again, the vault address must be HTTPS. This is so annoying. Why is anybody using this? Maybe nobody's using this anyway. I don't even know what it is, but I wanted to make it work. Okay, so I'm gonna add a certificate, and then we kill the agent and we start the agent again. Then we try this again with HTTPS, fetch field. Zero self-cert. Well, yeah, it's a self-signed certificate. Screw you. This is way too much hacking now already anyway. I'm gonna set this as my vault, TLS vault cert. Then I get permission denied again. Oh, great. So that didn't help me at all. Now I'm going through my agent, which is nice, but I'm still getting, in the end, the permission denied. So maybe this just shouldn't happen. I didn't plan to do that from the beginning anyway, but now I kind of wanted to make it work. I think I'm going to give up. I think I'm just going to kill this, delete this cluster. It was nice, but I will delete. Can try with local again. How did we do with local? We have a Solana key again. So instead of this, we use root. It's just a token. Then it will tell me to use HTTPS again. Transit sign my Solana key. Doesn't work. Temp vault. There we go. With the def TLS, it creates me a temporary vault certificate. We'll do that. And that. And that. And now for node, we need to add the certificate as well. So this certificate, we will also add as node extra CA certs. I should copy this. So that I set to this. And then I npx tsx my vault signing. There we go. Okay, we're getting somewhere. Return signature does not match public key and signed data. That's good because that's not my public key anymore. Now I need to first read my public key, which is this. I'll put my public key here and then try again. Look, we're getting somewhere. So this is my public key now. And now we get a transaction simulation failed. Woohoo! That's great. That's great because that just means that we don't have funds on that account because we don't. Context. Yeah, we don't really get much information from this, but I'm pretty sure that's because this address is just not funded. So Solana transfer to this address 0.01 sol and allow unfunded recipient. And then I try again. Boom! Yes! we send a transaction with this address that is stored in my local vault here. Nice. I can use the vault signer. Look, I can keep using my vault signer. Yay. Nice. Cool. What's the advantage of this? Well, my key now doesn't live in a local Keypair that is stored on my file system anymore. It's now somewhere in this vault that protects it, which, you know, it's a safer way to store your keys. And as we saw, I could have even run it on a cluster. We could even run this as an enterprise thing if we have the funds for it. So yeah, was somewhat complicated to set it up, this one actually, honestly, but we managed in the end. So yeah, Solana keychain, let's go. Do we want to try another one? No, it's enough for today. Thank you for watching. Cool. So we saw that the Solana keychain provides signing possibilities for many SDKs and that it's pretty simple to plug them in. Some are more difficult to get to work, like the vault, but others are super trivial. And I really like that there's this interface, this one way of writing it, and then I can just replace the API keys and it will work with a different technology. I like that. As a dev, makes it super simple for me. So yeah, I hope you like the Solana keychain as much as I do. Here's some other videos. You can like this one. You can subscribe if you haven't done that already. And I will see you in the next one. Okay, bye!